Hello everyone, welcome to my YouTube channel JanaAI. So in our previous tutorial we have discussed about artificial intelligence, machine learning, deep learning, different types of machine learning algorithms like supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. So in this tutorial we'll discuss about the key part of artificial intelligence tutorial, that is natural language processing, which is known as NLP. We'll discuss about the different type of application of NLP like machine translation, information retrieval and text summarization, chatbots application, storytelling and role playing application, question answering. We'll discuss about virtual or voice based assistants, and we'll discuss about topic modeling or text analysis. So let's start begin. So what is NLP? NLP means natural language processing is a subfield of linguistic computations and artificial intelligence. Okay, so you can see in our previous tutorial we have discussed about only the artificial intelligence. Okay, but in case of NLP, it's the subfield of combinations of computations knowledge and your the main task is your human language. Whatever the language we are telling, that is called the human language. So by combination of AI computations and human intelligence or human language, NLP forms, that is natural language processing, and it also tasks to interact between computers and the humans that allows the machine to understand the human language. Okay, this NLP, by this NLP means natural language processing, only a human can interact with the computer. Okay, so what we have done in our previously, when we are used the computer to talk with computer, we are using some algorithms, right? We are using some languages like C, C++, Java, Python to interact with the computer. But in case of NLP, about after the evaluation of NLP, so a human language, human can interact with its own linguistic forms, own language forms, can interact with the computers. So that is the main fundamentals of natural language processing. How to process your natural language, human natural language with the computers or machines. That is called the NLP, natural language processing. Okay. So now we'll discuss about the what are the building blocks of natural language in NLP. Then we'll discuss about what is language. A language is a structured system of communication that involves complex combination of its constituent components such as characters, words, and sentences. So language is the structural whatever language you are telling, that is the combination of that is the combination of communications that involves the complex combination of characters, words, and sentence. Okay, so the fundamental component is the human language. Let's discuss about the different building blocks of NLP. Okay, first is your phonemes. What is phonemes? Phonemes are the smallest distinct unit of a sound in a language. Whatever sentence or sound we are telling, phonemes is the smallest distinct unit. So let's say one example, like a word that is bat, pet or cat, whatever we are saying, the phonemes is the what is the difference, what is the difference here? You can see the slash b and slash p, this is the phonemes. Okay, this is the phonemes. At and at, both the words at and same, bat, pet, cat, like that, but the difference is you can see the slash b and slash p, whatever we are speaking, like bat for b at bat, then pet, cat, like that. So this is this smallest unit, this is called the phonemes of the word. Okay, so where it is used, it's used in your speech to text converter, speaker recognition, speaker identifications, use cases, NLP use cases, text to speech converter. So this type of use cases only we are using phonemes of the natural language building block. Okay, understand? Let's clear it. Now we will discuss about what is morphemes. Morphemes are the smallest meaningful units of the language. Okay, so this morphemes consist of words, prefix, and suffix. Let's say one example. If we have word like unhappiness, I have put one here. That is unhappiness. What is the morpheme here? This total form is the morphemes. It consists of three morphemes. One is the your un. That means that is the suffix, prefix. Sorry, prefix. This one is your prefix, and this is happy. This is your root word. Okay, happy. This is your root or base word, and ness. This is your suffix. So morphemes. There are three morphemes you can see. That is your prefix, root word, and suffix. So this type this is called the morphemes. Morphemes is the smallest meaningful units of a language. So here it is used for your tokenization, for tokenize of the sentence to a word. The morphemes is used. In case of word embedding techniques and the parts of speech techniques, only the morphemes used. Okay. Now we'll discuss about what is lexemes. So let's discuss about lexemes. What is lexemes? Lexemes are the words of group of words which with the same root with related meanings. Okay, they share the same core meaning but can have different inflections or grammatical forms. Let's see an example, then you'll be able to understand clearly. Let's say I have a root word that is run. Okay, so run has different lexemes. It had can different grammatical forms like runnings, runs. So this forms of words is called the lexemes. Understand? They are same kumbas, but the meaning is same, but the different grammatical forms. Where it is used, it's used in tokenization, word embedding techniques, parts of speech tagging, and all. Okay. Now we'll discuss about what is the syntax analysis. Syntax analysis in NLP. So what is syntax? Syntax refers to the arrangement of words to create meaningful sentence. Okay. Let's say I'm telling she sings a songs. So this is the syntax. This is the syntax. Okay. Means the how we are arranging the words. First one is your subject, then verb, then predicate. Okay. Or objects. What you are saying. So this is the syntax, how we are forming a sentence. Okay, syntax refers to the arrangement of words to create the meaningful sentence. It involves the rules of governing of words, phrases, clauses, and the sentence structures. Like first, when you are building a sentence, like she sings a song, first it will come the subject, then the predicate. She sings a song. That is the predicate. Okay, so where does the syntax is using? It is using for the parsings of the sentence, entry instructions, relation instruction. In this case of information retrieval, so this type of use cases, syntax is very much important. Okay, in case of NLP, in case of text, text data, when you are using the textual data, syntax is very much important. Okay. Now we'll discuss about what is semantics analysis in NLP. Semantics analysis deals with the meaning of words, phrases, and the sentence. It involves the understanding between the relationship between the words and how they convey the information. In syntax, we have seen that how the sentence is forming. But here in the semantic case of analysis, how the meaning of these words or sentences. Let's say what water. So what water refers to the water with high temperature. Okay, this is the semantic analysis. Okay, of a sentence. Okay, how the relationship to understand the relationship between the words and how they convey the information. Suppose this is the temperature, how much temperature it is, it's a high low like that. Okay, so this is called the semantic analysis. So now we'll discuss about another NLP pipeline, that is your context. What is context? Context is how the various parts of a language come together to convey the particular meaning. Okay. So in syntax, we have seen the how the okay, from the sentence how the subject then verb then predicate is coming. In semantic, we know that how the different word with a different form. What is the temperature of this word? Then in case of context, it is using the main thing, that is the to do the word knowledge, that is very much important. This term, that is the common sense. In context, when you are saying something, sentence, right, it using the main things, that is your context. In case of context, when you are giving some input, or you are giving some prompt to a LLM based model, or a NLP application, context is very much important. So context, to give the actual output, context is required. Like, say, if I'm saying the one example, the weather is good. Okay, this is also a sentence. But okay, but what is but that is this is meaningful. But here you can also the same word is used, but there is no sense, right, in this word. Weather is good. Okay, has the it has the common sense, but this sentence that does not have any common sense. Okay, so this in case of meaning of the word, in case of common sense of a sentence, common context is very much important. This is how the various parts of language come together to convey particular meaning. So where this context is using, it's used in complex NLP task. Okay, like the summarization, when you are summarizing of a text. Okay, let's say you have 10 pages of PDF, and you have to summarize, let's say 10 pages of PDF of a annual report of a particular company. You want to summarize. So at that cases, your context is very much important. The context of first pages will be the input of the pages of the last. Okay, like that, transformer architecture I will do in that. In case one, I'll tell you the transformer architecture, no? Then I'll do the how the a text summarization has been happen, which is using very much context. So that context, what you are summarizing, that is very important. The what are the meanings we are taking from the first for in case of summarization, no, that is very important. That is the to do a common sense, to do a good article, okay, good header, for good summary of a page or a book. So context is very much important, okay, to do a common sense. Okay, then in case of topic modeling or sentiment analysis, in case of any e-commerce company, suppose they have the millions of reviews, no, we have to understand the context of this per sentence. Okay, per sentiments, we have that whether this is a good sentiment or bad sentiment, positive or negative type of sentiments. In that case only, the context of a whatever I have shown in this example, the good way, that is there is no context, there is no common sense for this sentence only. So the context is very much important in case of complex NLP task. Okay, so be careful about that. Then we'll discuss about tokens. What is the tokenization in NLP? Okay, the tokenization or tokens are the basic units of a text that is processed by the NLP system. Okay, these are the basic units of a text or a sentence. Okay, they can be words, punctuation, marks, or numbers. Like that, I have a sentence: the cat sat on the mat. Okay, it's made of the one, two, three, four, five, six token. Right, the cat sat on and the, okay, and made. Okay, so this is the tokenization to yeah, break down the units of a sentence, that is called the tokenization. Okay, then we will discuss about the sentence. As you already know, the sentence has the basic units of communication of a language. And they are made up of words, phrases of the grammatically related to each other. Like that, whatever I have shown in case of tokenization, the cat sat on the mat. So in this sentence, you can see the subject. This is your subject, the cat. Okay, this is your subject. Okay, and sat on the mat is your predicate. So sentence combination of your subject and the predicate. Okay, so that forms a full sentence. Okay, then we'll discuss about one NLP pipelining, that is your stemming. So what is stemming in NLP? Stemming involves the removing the prefixes and suffixes from a words to get their root form. It's okay. It's used for pre-processing, text pre-processing task of NLP pipelining, simplify the words and improve the efficiency and accuracy of the various forms of NLP tasks. Let's have I have an example that like that you in case of when you are getting the data set, okay, NLP data set, okay, for your project. So in that data set you have a 100 lines of words, okay, 100 lines of words in your vector, okay, or a 1,000 lines of words in a vector. But in that thousand words, you can see the same meaning is coming from the different form, like that running, runs, like that. Okay, so stemmed hot, thus your stem analytical in analytical, I mean, what this stem technique, what it will do, it will extract the base word, okay, from this the original word. Okay, so it will improve your, when you are doing the training that model, when you are fitting that model, so it will improve the efficiency because it will remove that redundant data from your data set, from your vector data set, what you can say the vector data set. So it will increase your accuracy and the efficiency in case of NLP pipelining. So stemming, what it will do, it is trying to remove this whatever the prefix it has. Okay, it is trying to removing the prefixes and suffixes. Okay, and then in case of running, the after stemming, it will be like run. In case of jumps, it removes this is, okay, and it will form the jump. In case of swimming, it will remove the ing and it will form the swim. Okay, in this example, the stemming algorithm, what it will do, it will remove the suffix, okay, the ing suffix from the three words to obtain their root forms. Okay, it is removing this ing, s and ing, and it will form the root form. Okay, so this stemming algorithm is work like that. So it's very used in various use cases, like for your text summarization, information retrieval. This is very information, retrieval is the very common use cases, and the sentiment analysis in this, and there are question answering also, the chatbot application, conversation agent application also, stemming is widely used. Okay, understand? Now we'll discuss about what is lemmatization. What is lemma? So in case of stemming, what we can say, it is just removing the suffix. Okay, but there might not be that after removing the suffix, that base word might not be the in the dictionary. So to be a meaningful in the dictionary, so it's come the words to their base, reduce the words to a base is called the root form is called the lemma. Lemmatization consists of context. Context, consider the context of the of that word and the grammatical structure of the word. I mean, in case of stemming, there is no context or grammatical structure. It's just removing the suffix or prefix portion. But in case of lemmatization, it will convert it in your grammatical structure of the word. So and it will be in your match in your dictionary. Let's say I'm telling one example. Like, suppose you have a original word in your data set, like that you are getting running, jumps, better, cares, and was. What after lemmatization algorithm, lemmatization technique, what it will do? It will converting this running into a run. In case of jumps, it is in case of stemming also it is doing the run, but in case of jumps, it is doing your jumps. Okay, but in case of better, in stemming, it will not convert to good, right? It will convert to bet something. But in case of lemmatization, lemmatization, you can see it will convert your grammatical structure of better. Okay, it will convert from better to good, or best. If it is best, then it will convert from best to good. Okay, then in case of cats, a simple yeah, stemming technique, that is your cat. But in case of was, this is your fast form. In case of lemmatization, how it will convert, it will be convert to B. Understand? So this is the difference between your stemming algorithm and the lemmatization algorithm. So here it is used, it's used in your simple test classification, to classify of your test, and the information retrieval the key information from a, suppose let's say Wikipedia, whatever data source it has. Then in case of sentiment analysis, the lemmatization techniques is used. Okay, now let's discuss about what is parts of speech. The parts of speech tagging is identify the syntactic roles of a word, of each word within a sentence. Syntactic role of the word within the sentence, such as whether it's a noun, verb, objective, adverse, pronoun, preposition, conjunction. Okay. It's used the syntactic and the semantic analysis information retrieval machine. Okay. By determining the parts of speech of each word, NLP system can better interpret the meanings and the relationship with the sentence. In this example, here, suppose I am giving one example, the quick brown fox jumps over the lazy dog. So it will identify the quick. What is the here? Okay, so this is your DT, this is the tax. Okay, and this is the this is the form of the sentence. Okay, whether this is the yeah, what form? Okay, whether this is a determinator. Then quick, this is your JJ, means that this is your tag, and this is the description of this tag, that is your adjective. Then brown, this is your adjective. So here you can see in this sentence, this is your determinator, this is your adjective. This word is written means the identity as a, this word is identity as a adjective here, and in case of fox, here it is used as noun. In case of jumps, here it is jumps used as verb. Over means that is used as a preposition. This is the tag. Okay, determinator, then again the is used, that is your determinator. Then lazy, that is your adjective. Okay, then dot, this is your noun. Okay, so these are all and the dot, you can see you do know, you know that that is your punctuation. Okay, so in case so why it is using, because you can see in the different words this fox can be it can be act as your adjective or like that, or what can be act as your noun like that. So in a sentence, this particular word, okay, parts of speech, okay, this is the speech of a part of of the speech. Okay, so this words, single words, how it is how it is identifying the role of this sentence. Okay, like that we are using the parts of speech tagging algorithm. I'll discuss later when I'll do the algorithms and do the coding for this POC. Then I'll able to understand how it will different this POS algorithms using the analytical algorithm, how we are identifying this one. Okay, right. So where it is used in your means where the machine translation, speech recognition, information retrieval, and so on. Okay. Now we'll discuss about what is named entity recognition. In case of parts of speech entity, or let's say pipelining, we have discussed about in a sentence the various form for a particular words. What is the role of this in this sentence? But in case of a name entity recognition, no, NER, what you will identify? You will identify the it will identify the classify the name entities. Okay, in the sentence, it will identify the categories such as the persons, organization, location, dates, monetary values, percentage, and one. So I'll give you an example. Suppose I am telling one sentence or a text like that. I will be flying from London to Paris on June 1st, 23. Then this NAT name entity recognition algorithm, what it will do, it will try to identify the what type of entity it is. Okay, here in case of I, it will not find any entity. It is not belongs to this person's organization or location. But in case of will be flying, that is not also not an entity. But in case of London, it will identify in this sentence that's London. That is means that is a geopolitical entity. Okay, as a location or geopolitical entity. Okay, then two, this is not an entity, and Paris, this is also a geopolitical entity, and on this is not the, but in case of when you are getting this word, okay, that June 1st, 23, then it will identify, okay, yeah, this is a date entity. So in case of name entity, in a big sentence, okay, in a big paragraph, let's say, it will identify the what are the entities, main entities, what are the person entity, what are the organization, location, date, entities, and monetary values per percentage entity. So it will try to extract those entity, and by these entities only it will create a knowledge based graph. Okay, so these knowledge based graphs are very useful. Okay, for these are useful for the your information retrieval. Suppose if you want to retrieve the key information from this knowledge based, then this is very widely used. In case of question answering, let's say I am telling you an example, like say if you are in Google search, if you are searching like that, what is the capital of India, then it will try to pick up all the it will try to pick up the capital, means it has a entity. Okay, and India, this is a this is your geopolitical entity. Okay, like that it will map that graph, and based on the graph only it will fetch out the Delhi. What is the capital of India? That is the Delhi. Okay, it will fetch up that entity, location entity. So for to yeah, to do this question answering cases also, that NER is very widely used in named entity. In case of sentimental analysis or text summarization, okay, knowledge graph construction, name entity, this type of yeah, algorithms are widely used. Okay. Now we'll discuss about one of the embedding techniques, that is your word embedding. Okay, so this is very important when, because you know that in NLP medium heading only we have discussed about that how can a computer can interact with your human language. So to interact with the with our own human language to our computer, the embedding is very much important. How we are connect with the computer. Computer can understand only your numerical representation of the data only, right? So to convert this word, it means the textual data to numerical data. This to the technique is called word embedding. It represents the words or phrases to a dense or numerical vector of a continuous space or continuous vector or a multi-dimensional space. Okay, it's a converting your words or phrases to a dense numerical vectors. Okay, this is called a word embedding. Okay, it captures. It's not only converting this your text to a vector. It also captures the semantic relationship between the words and the enables the machine learning models to understand the contextual meaning of the words. Okay, it will also understand the by doing the different algorithms. I'll tell you the later. It will also try to understand the machine learning and understand the contextual meanings of the words also. Okay, what a many techniques are large numbers of the large corpus, whatever the data set we are getting, that is called the large corpus of text using the text like what to vector, global vector of word representation, fast text. These are all the word embedding techniques. Let's have an example. Assume that I'm just trying to the similarities between your king and queen. Okay, suppose in case of king, after wording embedding, what it will represent, that is your 0.8, that is your 2D array, that is 0.8 and 0.4. Okay, man, this is and that will be different your vector. This is woman, this is your vector, and this is the queen, this is your vector. Okay, then you will understand what is your analogy. Analogy is saying that king minus man plus woman is equal to, will identify. Like let's say vector result, vector king and vector man and vector woman. So we'll get the vector result by this. This is your vector result 0.6 cross 1.1. So we'll identify by doing the, suppose let's say this is your dimension, this is your x-axis and this is your y-axis. So we'll identify the, this is the two vector, okay, king and queen. Okay, we'll identify the instead of fetching the equilibrium distance, no, like how closely this king and queen words are related. So in case of equilibrium distance, no, so we'll identify between, suppose this value is your x and y1 and this is your x2 y2. Will identify by the equilibrium distance, root over of x2 minus x1 whole square plus y2 minus y1 whole square. But we will not discuss about in case of multi-dimensional spaces. Let's say in your our embedding techniques, when you are converting your text to your vector, the dimension will be high. So in the dimension will not find out the equilibrium distance to how closely this vector will vector will close to this vector. Okay, so we'll use the angle of this one. This is your theta, means angle, that is your cos theta. Okay, we'll find out the similarity of this cosine similarity between your king and queen. Okay, so like cosine similarity will identify this mathematics. Okay, that is your dot product of your vector king then vector queen divided by magnitude of your vector king and by magnitude of this one. Okay, then we will identify that dot product of 0.8 and here it is 0.9. Okay, vector, yeah, of king. Okay, that is vector queen is your, this was in case of vector of queen, that is your 0.9, right? We got, yes, this one is your zero point 0.9, and in case of zero point 0.4, and we will identify that is your 0.964. So it's close to 1, right? That means that means high quotient similarity means indicates that king and queen are likely to related to each other. So I am giving one example of word embedding technique. So by this word embedding technique, we will identify when you are getting the different type of different words in a vector. So by converting this word into a vector, we will identify the what are the questions similarities of this word, okay, by identify using the question similarity what I have discussed here, okay. So these are all our meeting techniques, and we'll discuss later about different types of NLP edge cases, algorithms, and NLP pipelining also. So that's all in today's lecture. So we have in this lecture we have discussed about the what is NLP, what are the use cases of NLP, and what are the language building blocks of NLP like syntax, semantics, lemmatization, then context, stemming, algorithms, and all. We'll discuss about we'll do a live projects also about this algorithms, about this NLP pipelining edge cases. So thanks all to thank you very much. So please don't forget to subscribe my channel. Please subscribe my channel to you, your friend and family. So our motto is to learn the new technologies like NLP. Then we'll discuss about the different types of NLP architecture. We will discuss about the different types of machine learning architecture of NLP use cases like support vector machine, by Bayes theorem. So then your classification program like logistic relation, decision tree, and so many random forest and all. We'll discuss about the RNN architecture, deep learning neural architecture of NLP use cases like RNN. Then LSTM we'll discuss on transformer architecture as well as your autoencoder, decoder, attention model. Okay, later on we'll discuss. So that's all in today's lecture. So if you want to more about NLP and all, you can buy our courses from our website. The link is in your video description. That is your https://janai.com. So you can log into our online portal and you can buy this course. So thank you very much.